Grab your hiking boots and welcome to This Explainer. I'm your guide, and today we're embarking on a massive expedition across the third largest continent on Earth, North America. We are going to explore exactly how the mountains, plains, and water systems completely define this incredible landscape. But before we even unpack our gear and set up base camp, I want you to ponder something for a second. If a single raindrop falls directly on the peak of the Rocky Mountains, which ocean does it actually end up in? Keep that in the back of your mind, because the answer reveals the truly epic scale of how landforms and water interact on this continent. We'll find out the exact answer when we reach the very peak of our journey. Here is the roadmap for today's trek, mapping our expedition, traversing the ancient East, the vast continental breadbasket, scaling the Western Wall, and finally, the Great Water Divide. Okay, Section 1, mapping our expedition, the base camp. Let's get the lay of the land. We are talking about a seriously massive chunk of rock here. North America isn't just large, it's the third largest continent on the planet, home to an estimated 580 million people. And we are completely surrounded by water. We're bordered by the freezing Arctic Ocean up north, the Atlantic to the east, the vast Pacific out west, and anchored by the warm Caribbean Sea down south. Because this massive landmass extends to within just 10 degrees of latitude of both the equator and the North Pole, we are playing in an incredibly diverse geographic playground. Let's move right along to Section 2, traversing the ancient East, shield and mountains. We're starting our trek in the East, which is basically the continent's foundation. We're talking about some of the oldest rocks on the entire planet. Moving inland from the Atlantic coastal plain, we hit what geologists call the Canadian Shield. It's this vast, incredibly stable platform of ancient Precambrian rock. Now, millions of years ago during the Ice Age, colossal continental glaciers sat right here. As things warmed up and those unbelievably heavy ice sheets receded, they literally gouged out the Earth, scarring the landscape and leaving behind endless lakes and wetlands, including, of course, the famous Great Lakes. You can really see the spectacular aftermath of those glaciers here. Those ancient glacial meltwaters carved out some absolutely vital water arteries, like the St. Lawrence River flowing right out of Lake Ontario. Today, the St. Lawrence isn't just a beautiful natural border between the US and Canada. It is a major shipping seaway that acts as a direct lifeline from the deep interior of the continent straight out to the Atlantic Ocean. Continuing our hike west, we run right into the Appalachian Mountains. Now, you have to notice the stark contrast here between the East and the West. The Appalachians in the East are incredibly old. They stretch roughly 1,500 miles from Canada all the way down to Alabama. But because they're so ancient, they've been worn down over millions of years by wind and water. It's crucial to compare these weathered eastern peaks with our ultimate destination today, the American Cordillera out west. Those western mountains are geologically young, highly active, and feature these jagged, towering peaks that cover a massive 1/3 of the continent. Descending from those ancient eastern mountains, we enter Section 3, the vast continental breadbasket, the Great Plains. We leave the mountains behind and step into the immense, flat interior of the continent. And here's what's so fascinating. Because North America stretches almost all the way from the Arctic to the equator, literally every single climate zone can be found here. This incredible north-to-south diversity directly fuels the staggering agricultural superpower that is our current stop. So why exactly is this broad expanse of prairie known as the breadbasket of North America? Well, first off, it boasts incredibly rich soil, which is an absolute must for high-yield farming. Interestingly enough, the extreme weather swings out here actually prevent large, deep-rooted plants from taking over, making it the perfect environment for native grasses to thrive. And depending on where you stand, the agriculture shifts beautifully. Up in the cool temperate zones, you've got cattle, corn, and orchards of apples and peaches. Head down to the warm subtropical zones, and farmers are pulling in abundant harvests of citrus, vegetables, and cotton. And practically the whole shebang is fed by one incredible source, the massive Mississippi-Missouri River system. 2,320 miles. That is the staggering length of the Mississippi River alone. It's one of the longest rivers in the entire world. When you combine it with the Missouri River, this sprawling watershed acts as the main artery hydrating this vast agricultural breadbasket. It's literally pumping the water that grows the food on your dinner table. But we can't stay in the plains forever. Let's tackle Section 4, scaling the Western Wall, the Cordilleras. Leaving the flat prairie behind, we are forced to look straight up. We've hit the towering western wall of the continent. The Western Cordilleras are a complex, rugged belt of young mountains, plateaus, and basins. And when geologists use the word young, they mean they formed as recently as 65 to 100 million years ago. Taking up a full third of North America, this is a highly active tectonic zone sitting right on the Pacific Ring of Fire, anchored by the massive Rocky Mountains on the east and the Pacific Margin on the west. To really wrap your head around the dramatic vertical scale of these young mountains, consider this number, 20,320. Standing at 20,320 feet, Denali, way up in the Alaska Range, is the highest peak in all of North America. It is a perfect reminder of just how rugged, tall, and geologically active this entire western edge really is. Now, the hydrology hidden inside these mountains is completely wild. Within this western region, we find amazing geographical extremes, sculpted entirely by water. On one hand, you have the Great Basin. It's this vast interior watershed covering much of Nevada and Utah, where water flows down from the mountains, but gets trapped. It never actually makes it to the ocean. Contrast that with the Grand Canyon down in Arizona. Over millions of years, the mighty Colorado River carved a steep-sided canyon through solid rock that is 277 miles long and over a mile deep. It is just a breathtaking display of water's relentless power. Which brings us right to our final peak. Section 5, the Great Water Divide, the Continental Roof. We made it, the summit of our journey, the Great Divide. This is North America's major continental divide, running north and south straight through the Rocky Mountains. The absolutely crucial thing to understand here is that this jagged, towering mountain ridge acts as an impenetrable physical wall. It literally dictates the directional flow of all the major water systems on the continent, forever separating the ultimate destiny of all that rushing water. So let's bring back that raindrop from the very beginning of the explainer. If that single raindrop falls on the western side of the Great Divide, it is going to tumble down rivers like the Colorado, the Columbia, the Yukon, or the Fraser, ultimately flowing out into the Pacific Ocean. But if it falls just an inch to the east of the divide, it embarks on a completely different, epic journey. It'll flow down the Mississippi, the Missouri, or the Rio Grande to eventually dump into the Atlantic Ocean or the Gulf of Mexico. One singular mountain ridge decides the fate of trillions of gallons of water. And this isn't just fun geological trivia. This stuff actually matters to us. These rivers are vital for irrigation, fishing, generating hydroelectricity, and as massive navigation routes for shipping. Long before European colonization, these water systems, completely dictated by the towering mountains above them, were recognized as a precious, limited resource, held sacred by Native American tribes. And today, they remain the absolute lifeblood of modern civilization across the entire continent. So as we wrap up our trek today, I want to leave you with this question. The next time you look at the ground beneath your feet, are you just going to see dirt, or are you going to see the results of ancient geological forces that are literally shaping the water you drink and the food you eat? Our expedition proves that geography is so much more than drawing lines on maps. It's the epic, ongoing story of the Earth beneath us. Thanks so much for exploring with me.